Welcome. In this session, we'll learn the different discrete time versions of the important signals that are sine wave, unit step signal, unit sample function, and the ramp function. Let's start. Let's start with the famous sine wave. Let me switch to Matlab. So this is our Matlab. So let's first start with this discrete sine wave. So let's suppose the time varies from minus 25 to 25. So this is our time axis. So n stores our time axis, and the value of this time varies from minus 25 to 25. Next, we are going to create the sine wave. And how we do that? Whatever is stored in n, we calculate the sine of that value by doing this. And next, what we are going to do, we are going to plot it. But to have a discrete version of this sine wave, we are going to do in Matlab one more function, that's the stem command. So stem function, we are going to use this. So this is n comma x. Now I'm going to change the color of this plot. I'll say it's red, and then I will set the line width of this plot as 3. And I'm going to name this plot as, so to name this plot as, let's name it discrete sine wave. So this will be named as discrete sine wave. I'm going to turn on the grid. I'm going to turn on this grid. Now to see the results, let me switch to the figure window. So this is our sine wave, and this is our discrete sine wave. You can see this is the discrete sine wave. All right, so this is how we create the discrete sine wave in Matlab. Next, what we are going to do, we are going to see the unit step sequence in Matlab, or unit step signal in Matlab. I mean, the discrete version of unit step signal. All right, let's suppose, first let me give you the simple way, means using simple manipulation. Let's suppose the time varies from minus 5 to 5, means our time axis varies from minus 5 to 5. Then I'm going to create a sequence that I named as step. Then what we are going to do, we are going to set the values in this array as like this. So this is our step sequence. You can see it is 0. It has zeros and ones in it. So how do we do that? Now next, what we are going to do, we are going to plot the step sequence. So for time t, and the name of this sequence is step, and I'm going to change the color of this plot. So let's set it red, and I'm going to also set the line width of this plot. Let's set it to 3, and let's name this plot. Let's call it unit step sequence. So this is our unit step sequence. Next, what we're going to do, we're going to turn on the grid. Now to see this plot, I'm going to switch to the figure window. You can see this is our unit step sequence. It is 0, power minus 1, minus 4, minus 3, minus 2, minus 1, and it becomes 1 at 0, then it's 1 everywhere, you can see. So this is the unit step sequence from minus 5 to 5. Now, next what we are going to do, we are going to generalize, means if we generalize this step sequence, means if we want this step sequence from any time to any time. Let's suppose we want this unit step sequence from minus 10 to 20. So we want to plot this unit step sequence for time minus 10 to 20. So I will first define the time axis. This is our time axis. Then I'm going to create the step sequence. Now to create this step sequence, what I'm going to do, I'm going to again use the Matlab's comparative operators, means to calculate this step sequence or compute this, create this step sequence. What we are going to do, we are going to use Matlab's this comparative operator. Now what do we mean by comparative operators? So the comparative, this is the first comparative operator. Now what this does, this checks what's on the left hand side of this equal to double equal to operator, and what's on the right hand side. If these two are equal, Matlab says that this is true, and it assigns 1 to this variable. So if this is true, if this statement is true, means if this instruction is true, Matlab will say yes 1, and it will answer 1. It will answer this as 1. You can see the answer is 1 because the statement is true or correct. So the answer is 1. Same way, if I say 1 is equal to 0, we know this statement is false. 1 is not equal to 0, so Matlab will say this is equal to 0. So you can say this is the answer is logical 0. So this is one this operator. Same way we can say 1 is equal to -2 as this statement is false. Matlab will say this is false statement by us answering that the answer to this instruction or the statement is 0. Same way we can say 1 is greater than 0. This is true. So Matlab will say 1. Same way we can say 1 is greater or equal to 0. This is again true. So Matlab will say 1. So these are the operators in Matlab. These are the comparison operators in Matlab. So what we are going to do, we are going to use these operators. So let me say the time axis varies from -10 to 20. So we are going to plot this step sequence, means we are going to plot this step sequence from -10 to 20. So this is our time axis. Next, what we are going to do, we are going to create the step sequence by using these comparison operators. What we are doing, we are saying wherever n is greater or equal to 0, make it equal to 1. That's what this statement will do. This will say, this will compare every value of this n with this 0. So wherever n is greater or equal to 0, it will assign 1. The rest values will be 0. You can see the first 10 values are 0. First 10 values are 0 because these values are less than 0. So these are not greater or equal to 0, so it assigns 0, and the rest of the values are 0. Next, what we are going to do, we are going to plot this. So we say stem n comma step. Then let's suppose the color of this plot we set as red. And next, what we are going to do, we are going to set the line width of this plot, and that's 3. And I'm going to name this plot as unit step sequence. Unit step sequence, and I'm going to turn on the grid. As I grid on now to see the result, let me switch to the figure window. So this is our unit step sequence plotted from -10 to 20. All right. So now what we are going to do, we are going to see the shifted versions of this unit step sequence. So we'll see the shifted versions of this unit step sequence. Again, I'm going to use the Matlab's this comparison operator to do that. Let's suppose the time axis varies from -10 to 10. So this is our time axis. And next, what we are going to do, we are going to create a step. So this is our step, and we'll use a Matlab's this. Let me terminate this. Next, what we are going to do, we are going to give it a shift of 1 unit. So this is shift of 1 unit. So this will be stored in 1. So what I'm doing, I'm just comparing the result with 1 now, not with 0, but this 1. So this will be a unit step sequence. With this will be this shift unit step sequence, but the shift here is 1 unit. Same way, what we are going to do next, we are going to give it a shift of 5 units. So we'll store that in step 2. Then we are going to give it a shift of -3 units, means we are going to shift it towards the left. Let's store it. Now what I want to do next, I want to see these plots on the same window, means on the same plot window. So to do that, Matlab has one more function that's called a subplot function to plot these different sequences on the same plot. So what we do, we say subplot, and this 2, 2 means there will be 2 rows and 2 columns of these plots there, and this one means this is we are currently working on the first plot. So what I do, I say stem n comma step. So this will be our first plot, and let me change the color as red, and let's suppose the line width is 3. So this is our line width, and I'm going to turn on the grid, and I'm going to title of this plot, I will say unit step sequence. So this is our unit step sequence. Now next, what we are going to do, we are going to plot this shifted unit step sequence, means that has a shift of 1 unit. That has a shift of 1 unit, and I'm going to plot it on this. So let's use the color as blue. B is blue, and then we are going to turn on the grid, and we are going to name it delay one step sequence. This is a step sequence that has a delay of 1. Next, what we are going to do, we are going to plot, have the third plot, and this we will plot on this, and let's suppose a color that we use is black this time, and this on this we are going to this has a delay of 5 units, and we are going to turn on the grid. Next, what we do, the fourth plot, we will have, I think this should have this to do that. This is 2 actually. This is 2. Alright, so this and this, plot this on this, then say grid on. Next I'm going to plot this. So then I'm going to plot the delayed version that delay towards the left, and I'm going to use Matlab's in the color. So Matlab will assign the color itself. So this is a delay, a time advance of 5 advance 5 unit advance 5 units sequence, and I'm going to turn on the grid. Now to see the result, let me switch to the figure window. Let's see this. You can see this is our original unit step sequence, and this one is our unit step sequence that is delayed by 1 unit. This is delayed by 1 unit. This is delayed by 5 units. This is time advanced by 5 units. This is how we see these, how we create these unit step sequence, and it is delayed and time advanced versions in Matlab. All right, so this is about unit step sequence. Next, what we are going to do, we are going to create the unit sample sequence. So the next what we do, we create the unit sample sequence, or the unit impulse in discrete time. So let me first define the time. Let's suppose the time varies from 5. Then I'm going to create an array that stores this impulse sequence, and the values are 0, 1, 0. So this is our impulse sequence. And next, what we are going to do, we are going to plot it by using the step function, and the color I will set as red. Line width I will set equal to 3. Then I'm going to name this plot, and I say this is unit sample sequence. So this is our unit sample sequence, and I'm also going to turn on the grid. So to show you the result, let me switch to the window. First I must, so let me do it again, because title is, now we can see the result. So this is the unit sample sequence. So you can see this is our unit sample sequence. This is plotted from -5 to 5, and the value is 1 at n equal to 0. Rest of the sample values are 0. So this is the simple unit step sequence. Next, what we are going to do, we are going to use the Matlab's this comparative comparison operators give create this. So what we do, we say n is from -10 to 15, means we are going to plot this unit sample sequence from -10 to 15. Then we create this impulse sequence, and this impulse sequence we create using the Matlab's this comparison operator. Next, what we are going to do, we are going to plot it. So this will plot that, and we are going to turn on the grid. Let me show you the plot. So this is how the plot looks. So this is our plot. So this is the unit step sequence plotted from -10 to 15. All the sample values are 0 except when n is equal to 0. Now next what we are going to see, we are going to check the different shifted versions of this unit step sequence. All right, so let's do that. Let's say n varies from -10 to 10. For simplicity, so this is our time axis, so n will vary from -10 to 10. Next, what we are going to do, we are going to create the impulse sequence. Again, this we are going to create by using this comparison operator. Next, what we are going to create, I'm going to create a shifted version of this. Let's call it impulse 2. We are going to do it like this. So this, what will this statement do? This will compare n. When n is equal to 2, it will be equal to 1. Rest of the values will be 0. That's what we want actually. So then we create a delay of 5 units. Sorry, this should be named as, let's call it impulse 5. And impulse 2 is this. And next what we are going to create, we are going to create an impulse of -5, as we will shift this towards -5. Let's say this is -4, and we will call it impulse -4. Can it assign this? Impulse 4. All right, so this is how we create this sequence. Next, what we want to see these impulses on the same plot window. Means we are going to see on the same window all these plots on the. So for this again, I'm going to refer to the subplot. It's 2, 2 means there will be 2 rows of these plots, 2 columns of these plots, and this means the first plot among those. So we are going to use stem. Let me use the already defined command. So this is our, and I'm going to name it unit step sequence. And I'm going to turn on the grid. This is how we go to the preview. Just clicking on the up arrow button. Next, what we are going to do to go to the second plot, we are going to go to this, and the name of this is impulse 2. This we'll see in blue color. Rest we are going to keep. So this is our delayed unit step sequence, and it is delayed by 2 units. We are going to turn on this. Next, what we do, we are going to call third plot, and to see that, let's say the color is orange. Not orange, let's say color is black. So the color I set as black. So this is again the delayed. Next, I'm going to, sorry, this is not 2, this is 5. So it should be 5. Now this I will call as 4. Then I'm going to call it impulse underscore 5. And we are going to let Matlab choose the color this time. I think it is impulse 4. Sorry, impulse 4. The name is not impulse 5. The name is impulse 4. That's why this gave an error. So this is time advanced. This is time advanced by 4 units. So this is advanced unit step sequence. You can see time advanced step sequences. Let's turn on the grid and let's see the plot now. So let's see the plot. Okay, let me see. This is our unit sample sequence, and this is plotted for values of time -10 to 10, and this is the original unit step sequence. Next, you can see this is a delayed unit step sequence, and it is delayed by 2 units of time. The next sequence here, I haven't turned on the grid in this line. You can see this is delayed 5. This unit sample sequence is delayed by 5 units, and this is the plot of that. This one is the time advanced unit sample sequence, and this is time advanced by 4 units of time. All right, so this is how we plot unit sample sequence in Matlab, or how we create unit sample sequence in Matlab. Next, what we are we're going to create the wrap sequence. Now to create the wrap sequence, if let's suppose the time varies from -5 to 10. So this is our time axis. Next I'm going to create the wrap axis, wrap sequence, and the values we know wrap sequence as value 0 for negative time, then 1. And this is the wrap sequence has a value equal to n. So wherever n, so whatever is the value of n, that will same value be true for. So I just gave an error because I didn't close the braces here. So this has values of 1 up to 10. Now next what we are going to do, we are going to use call the step command and plot this wrap function, and I am going to use red color for this plot, and the line width is, let's set it 3. Let's put a title on this and we'll say wrap sequence, UENC sequence, and then we are going to turn on the grid, and then let's see this plot. So what this is going to do before I share it, I'm going to run these commands again. So let's see the plot. So this is our wrap sequence plotted from -5 to 10. You can see the value of the sequence is same as n. Whatever is the value of n, that is the value of the sequence. All right. Now let's see how we create this wrap sequence by using UnitStep sequence. All right. So let's define n is from -10 to 20. Let's suppose the time varies from -10 to 20. All right, so this is the time axis. Next, what we are going to create this wrap sequence, and we are going to use UnitStep sequence. How we created UnitStep sequence, we are going to do that. So multiplying n is an array, and multiplying this with this array that I have put in square braces. That's wherever. This is our UnitStep sequence. So this array is UnitStep sequence. Actually, if you have a look at this is the UnitStep sequence. I think I have, this should be greater or equal to something, greater or equal to 0. All right, I forgot that, the right hand side. So this is our now. Next, what we are going to do, we are going to plot it. Then I'm going to use, let me show you the plot. You can see this is the unit wrap sequence. So this is how we plot unit wrap sequence. Also, you can create the delayed versions of this same way. You can create the delayed versions of this sequence same way. So this is the unit wrap sequence, simple unit wrap sequence. Now next, what we are going to do, we are going to create the delayed versions of this. Let me show you how to create the delayed versions of this. So this will have a delay of 3 units. Same way, next, this will have a delay of 5 units. Let's suppose now 7 units, not 5, but 7. So 7. Next, what we are going to do, we are going to create a wrap of -3 units. So -3. So let's not create that. Let me show you only 2 this time. Rest you can create So I will say subplot 2, 1, 2. So now I will have only 2 rows. Let me not use 2 rows. Let's use 2 columns. See the 2 columns on this. Only 2 plots. Then I'm going to call this stem function. Say n, wrap. So this is our original sequence. Then I'm going to turn on the grid. I'm going to name this by using the title command. So this is unit simply wrap sequence. So this is our wrap sequence. Next, I'm going to call this second window, and I'm going to call ramp 3. So this is delayed by 3 units. So we'll call it delayed ramp. Delay ramp sequence, and I'm also going to turn on the grid now. Let's see the plot. You can see this is our plot. So this is the original ramp sequence. This is the delayed, and this is delayed by how many units? 1, 2, and 3. So this is delayed by 3 units of time. So this is how we create the unit ramp sequence. So in short, this is how we create the different important these signals or sequences in Matlab. Why I'm showing this? This is very, very important for if we want to analyze any discrete time system. So this will be used later when we study different discrete time systems and continuous time systems. That's why we are studying this. All right, let me end it here. Please practice this because we are going to use these later.